Maria Santos wiped her hands on her worn apron as she stepped out of the small repair shop, tucked between a bakery and a laundromat on Maple Street. The faded sign above her door read, "Maria's Fix-It Shop" in peeling blue letters. Most people in the neighborhood knew her as the quiet woman who could fix almost anything, from broken toasters to squeaky bicycle chains. What they didn't know was that Maria held 2 engineering degrees from prestigious universities, achievements she kept hidden like precious secrets. The morning sun cast long shadows across the cracked sidewalk as Maria unlocked her shop. Inside, the cluttered space told the story of countless repairs. Shelves lined the walls, packed with spare parts, tools, and half-finished projects. A workbench dominated the center of the room, its surface scarred from years of use. This was her sanctuary, the place where she could lose herself in the satisfying work of bringing broken things back to life. Maria had inherited the shop from her uncle 3 years ago, after losing her high-paying job at a tech company. The corporate world had been unkind to her, dismissing her ideas and overlooking her contributions simply because she was a woman, and worse, because she spoke with a slight accent. The endless meetings where men talked over her, the projects where her innovations were credited to others, and the constant feeling of being an outsider had worn her down. When Uncle Roberto passed away and left her the shop, she saw it as a chance to start over, to work with her hands instead of fighting boardroom battles. The neighborhood initially viewed her with skepticism. How could this small woman in simple clothes possibly fix their appliances? But Maria proved them wrong, one repair at a time. She fixed Mrs. Chen's ancient sewing machine that 3 other repair shops had declared hopeless. She restored young Tommy's gaming console after he spilled soda on it, saving the boy's entire summer. Word spread slowly but surely that Maria could work miracles with broken things. On this particular Tuesday morning, Maria was testing a repaired coffee maker when she heard a commotion outside. Through her window, she watched as a sleek black sedan pulled up to the curb, completely out of place in her modest neighborhood. The car's engine purred with expensive precision, and its polished surface reflected the morning light like a mirror. Maria continued her work, assuming the driver was simply lost and would soon move along. The coffee maker gurgled to life, filling her cup with perfectly brewed coffee. She smiled, satisfied with another successful repair when the shop's bell chimed. Maria looked up to see a tall man in an expensive suit standing in her doorway. He looked around the cluttered shop with barely concealed disdain, his nose wrinkling as if he smelled something unpleasant. His shoes probably cost more than Maria made in a month, and his watch caught the light like a small sun on his wrist. "Are you the owner?" he asked, his voice carrying the authority of someone accustomed to being obeyed immediately. "Yes, I'm Maria. How can I help you?" she replied, setting down her coffee and wiping her hands once more. The man stepped inside cautiously, as if afraid the cluttered shop might contaminate his perfect appearance. "I'm James Richardson, CEO of Richardson Technologies. I have a problem that requires immediate attention." Maria nodded politely, though the name meant nothing to her. She had deliberately avoided keeping up with the tech industry since leaving it behind. "What needs fixing?" James reached into his briefcase and pulled out a sleek device about the size of a tablet, but thicker and covered in ports and indicators. "This is a prototype of our latest quantum processing unit. It's worth millions of dollars in research and development. Our entire engineering team has been working on it for 2 years. He placed the device carefully on Maria's workbench, treating it like a fragile piece of art. Yesterday, during a crucial demonstration for our investors, it simply died. No warning, no error messages, nothing. Our team of PhD engineers has been working on it around the clock, and they can't even figure out what's wrong with it." Maria examined the device without touching it, noting its elegant design and sophisticated construction. "And you brought it to me because—" James's expression grew uncomfortable. "Because we're desperate. The investors are threatening to pull their funding if we can't demonstrate a working prototype by Friday. That's 3 days from now. We've contacted every specialist we know, called in favors from other companies, even reached out to university professors. Everyone says the same thing. Without the original design specifications and proprietary components, it's impossible to diagnose the problem." "So you came to the neighborhood fix-it shop," Maria said, a slight smile playing at the corners of her mouth. "My assistant lives in this area. She mentioned there was a woman who could fix anything. I know it sounds ridiculous, but I'm out of options." James looked around the shop again, his doubt evident. I mean, no offense, but this is probably beyond what you normally work with. Maria picked up the device, feeling its weight and examining its construction more closely. Her trained eyes immediately spotted several design elements she recognized from her own work in quantum computing years ago. The irony wasn't lost on her. She had probably forgotten more about quantum processing than most engineers would ever learn. What makes you think it's impossible to fix? She asked, her fingers tracing the device's edges with professional interest. The quantum processors are incredibly sensitive. They require specific environmental conditions, precise calibration, and specialized equipment that costs hundreds of thousands of dollars. Plus, the security protocols mean that even our own engineers need special clearance to access certain components. Maria set the device down and looked directly at James for the first time. There was something in her eyes that made him pause, a confidence that seemed at odds with her humble surroundings. I'll need to keep it overnight to properly diagnose the problem, she said simply. James laughed, but there was no humor in it. Look, I appreciate the offer, but this isn't a broken television or a jammed printer. This is cutting-edge technology that represents the future of computing. Then why are you here? Maria asked calmly. The question hung in the air between them. James realized he was trapped by his own desperation. He had come here precisely because conventional wisdom said it was impossible, and yet he couldn't bring himself to trust this simple woman in her cluttered shop. If I leave this with you and something happens to it, my company will be ruined, he said finally. Maria shrugged. Then take it back to your PhD engineers. I'm sure they'll figure it out eventually. James stared at the device, then at Maria, then back at the device. The clock was ticking, and he was running out of time and options. James Richardson stood in the cramped repair shop, his internal battle written across his face. Every logical part of his business-trained mind screamed that leaving $1 million prototype with a neighborhood repairwoman was insane. Yet here he was, having exhausted every other option, facing a deadline that could destroy everything he had built. What's your usual rate for diagnostics? He asked, surprising himself with the question. $50, Maria replied without hesitation. James almost laughed at the absurdity. His company had already spent more than $50,000 on consulting fees from various experts, none of whom could even identify the problem. And if you actually fix it? We'll discuss that if it happens, Maria said, her tone suggesting she wasn't particularly concerned about payment. The confidence in her voice unsettled him. Most repair people he encountered were eager to discuss money up front, especially when dealing with expensive equipment. Maria seemed more interested in the challenge than the profit, which struck him as either refreshingly honest or dangerously naive. I need some kind of guarantee, James said, though he knew how ridiculous that sounded given the circumstances. Maria walked over to a filing cabinet and pulled out a simple form. Standard repair agreement. If I can't fix it or if I damage it further, you pay nothing. If I make it worse somehow, I'll compensate you for the original value. James read the form twice. It was straightforward to the point of being primitive compared to the complex contracts his lawyers usually prepared. More importantly, it put all the risk on Maria's shoulders. You're willing to guarantee a device worth millions of dollars? I'm willing to guarantee that I won't make it worse than it already is, Maria corrected. Right now it's completely dead. That's pretty much as bad as it gets for an electronic device. James found himself nodding despite his reservations. She had a point. The prototype was already worthless in its current state. What exactly would you need to do? First, I'll need to open it up and trace the circuitry. Then I'll test each component systematically until I find what failed. Depending on what's wrong, I might be able to repair it, or I might need to fabricate replacement parts. Fabricate replacement parts? James's eyebrows shot up. These are custom quantum processors. You can't just order them from a catalog. Maria smiled for the first time since he had entered her shop. Mr. Richardson, do you see that radio on the shelf behind you? James turned to look at an ancient-looking radio with a wooden case and brass dials. Yes, that's a 1940s Philco. When I got it, half the internal components had deteriorated beyond recognition. The original vacuum tubes were cracked. The capacitors had leaked and several resistors had burned out. The original manufacturer stopped making replacement parts 70 years ago. So how did you fix it? I made new parts. I fabricated vacuum tubes using glass tubing and tungsten wire. I wound new coils and built new capacitors using techniques that were common in the 1940s, but are forgotten today. That radio now works better than it did when it first left the factory. James stared at the radio, then back at Maria. But quantum processors aren't the same as vacuum tubes. No, they're not. They're more complex, but the principle is the same. Every piece of technology, no matter how advanced, is built from basic components following fundamental laws of physics. If you understand those laws and have the right tools, you can fix anything. What tools do you have here that could possibly work on quantum processors? James asked, gesturing around the cluttered shop. Maria led him to a corner of the shop he hadn't noticed before. Behind a canvas tarp was a collection of equipment that looked distinctly out of place in the humble repair shop. There was an electron microscope, a precision milling machine, a chemical etching setup, and several devices James didn't recognize, but that looked expensive and sophisticated. I inherited more than just the shop from my uncle, Maria explained. He was quite the collector of scientific equipment. Most of it came from university lab closures and corporate liquidations. James examined the equipment more closely. Some of it was clearly vintage, but it was all meticulously maintained and appeared to be in working condition. The electron microscope alone was worth more than most people made in a year. This is incredible, he admitted. But do you actually know how to use all of this? Mr. Richardson, may I ask you something? Maria said instead of answering directly. Sure. What do you think I did before I opened this repair shop? James looked at her carefully for the first time, really seeing her instead of just his preconceptions. There was intelligence in her eyes that he had initially missed, a quiet confidence that spoke of deep knowledge rather than simple confidence. Her questions about his device had been surprisingly sophisticated, and her willingness to guarantee such expensive equipment suggested she had reason to believe in her abilities. I honestly don't know, he admitted. I spent 15 years in the tech industry. I have a master's degree in electrical engineering from MIT and a PhD in quantum physics from Stanford. I've published papers on quantum coherence and held patents on processing architectures that are probably incorporated into your device. James felt his assumptions crumbling around him. Then why are you running a repair shop in this neighborhood? Because I got tired of having my ideas stolen by men who thought a woman couldn't possibly understand complex technology. I got tired of being passed over for promotions despite having better qualifications than my colleagues. I got tired of fighting for respect in every meeting and having to prove my competence over and over again. The bitterness in her voice was unmistakable, but it was controlled, refined by years of experience. James recognized the feeling. He had seen talented women leave his industry for similar reasons, though he had never thought much about it from their perspective. So you gave up a lucrative career to fix toasters and radios? I gave up a career that was slowly destroying my love for engineering to do work that reminds me why I became an engineer in the first place. Every device that comes through that door is a puzzle waiting to be solved. I don't have to attend meetings where men interrupt me every time I speak. I don't have to watch less qualified people get promoted over me. And when I fix something, the person who brought it to me is genuinely grateful. James looked around the shop with new eyes. What he had initially seen as clutter now appeared to be the organized chaos of an active laboratory. The woman he had dismissed as a simple repair person was revealed to be exactly the kind of expert he had been desperately seeking. Why didn't you tell me this when I first walked in? He asked. Would you have believed me? A woman in a repair shop claiming to have advanced degrees in quantum physics? Or would you have assumed I was lying to impress you and inflate my prices? James considered this honestly and realized she was probably right. His first instinct would have been skepticism, especially given his preconceptions about what a qualified expert should look like. So will you take the job? He asked finally. I'll look at your device, Maria said, but I have conditions. James shifted uncomfortably as Maria laid out her conditions. He was used to being the one setting terms, not accepting them from others, especially not from someone he had initially dismissed. First, Maria said, you don't hover over me while I work. I can't concentrate with someone breathing down my neck, especially someone who doesn't trust me to begin with. That's reasonable, James agreed, though part of him wanted to supervise every moment the device was out of his sight. Second, you don't tell anyone where you brought it. I'm not interested in becoming the go-to repair shop for Silicon Valley executives. I like my quiet life here. James nodded, understanding her desire for privacy. And third, If I fix it, and I'm saying if, you pay me what you would have paid any other consultant with my qualifications. I don't want charity, and I don't want to be shortchanged because I work out of a neighborhood shop. How much are we talking about? James asked. Though money was the least of his concerns at this point, my standard consulting rate when I worked in the industry was $500 an hour. Given the urgency and complexity of this project, I'd say a flat fee of $20,000 if I succeed. James almost smiled. His company had already offered twice that amount to several consultants who had been unable to even identify the problem. Deal, he said quickly before she could change her mind. Maria studied his face, surprised by his immediate acceptance. You agreed to that pretty fast. Because I've already spent more than that on consultants who couldn't help. If you can actually fix this thing, $20,000 is a bargain. She signed the repair agreement and handed him a copy. I'll call you tomorrow with an initial assessment. Do you have a number where I can reach you? James handed her his business card, then hesitated at the door. Maria, can I ask you something personal? You can ask. Do you ever regret leaving the tech industry? Don't you miss the cutting-edge projects, the resources, the recognition? Maria looked at the quantum processor on her workbench, then back at James. Mr. Richardson, in 15 years in the tech industry, I never once had someone seek me out specifically because they believed I could solve a problem nobody else could. You came here today because you were desperate, but you still came. That's more respect than I got from most of my former colleagues. After James left, Maria locked the door and turned off the main lights. She made herself a fresh cup of coffee and settled at her workbench with the quantum processor. Under the bright LED work lights, she began her examination. The device was beautiful in its complexity. The outer casing was crafted from a special alloy designed to minimize electromagnetic interference. When she carefully removed the screws and lifted the top panel, she revealed layers of circuit boards, cooling systems, and quantum processing units arranged with the precision of a Swiss watch. Maria had worked on similar devices during her industry days, though this one incorporated several innovations she hadn't seen before. She photographed everything before disturbing any connections, creating a detailed record of the original assembly. The quantum processors themselves were housed in specialized chambers designed to maintain the extremely low temperatures necessary for quantum coherence. She checked the cooling system first, suspecting it might be the culprit. Quantum processors were notoriously sensitive to temperature fluctuations. The cooling system appeared to be functioning correctly, though she noticed some unusual wear patterns on several components. She made notes and continued her investigation, working systematically through each subsystem. 3 hours later, she found the first clue. One of the power regulation circuits showed signs of thermal stress. The components were rated for the voltages they were handling, but Maria suspected they were operating too close to their limits. In her experience, engineers often pushed components to their maximum ratings to optimize performance, not accounting for long-term reliability. She traced the power circuits carefully, using her electron microscope to examine the semiconductor junctions at the microscopic level. What she found confirmed her suspicions. Several transistors showed early signs of thermal degradation. They were still functioning but not at full capacity, which would explain why the device had failed during a demanding demonstration. But thermal degradation was usually a gradual process. For the device to die suddenly, there had to be something else. Maria continued her investigation, following the power traces deeper into the circuit. At midnight, she found it. Hidden deep within the device's architecture was a protection circuit designed to shut down the system if certain parameters were exceeded. It was a smart safety feature, but it had been triggered by the cascading effects of the degraded power components. The protection circuit itself was undamaged, but it wouldn't reset while the underlying power issues remained unresolved. Maria smiled to herself. The device wasn't broken in the traditional sense. It had simply protected itself from damage by shutting down when it detected problems in the power supply. She could fix this, but it would require replacing several components with improved versions that could handle the thermal stress better. Fortunately, she had most of what she needed in her inventory of salvaged parts. For the specialized quantum processing components, she would need to be more creative. Maria spent the next 2 hours designing replacement circuits using components she could either fabricate or modify from her existing stock. It was like solving a complex puzzle. finding ways to improve the original design while maintaining compatibility with the existing system. By 3 in the morning, she had a complete repair plan. She could fix the immediate problems and implement improvements that would prevent similar failures in the future. The irony wasn't lost on her. She was about to make a $1 million device more reliable than its original designers had managed. Before going home, she called the number on James's business card, expecting to leave a voicemail. Instead, he answered on the first ring. "Richardson here. Mr. Richardson, this is Maria. I know it's late, but I thought you'd want to know. I found the problem." There was a long pause. "You found it? Already?" "Yes, the good news is that your device isn't really broken. The bad news is that it has some design flaws that caused it to shut itself down for protection. Can you fix it?" "I can fix it and make it better than it was originally. But I'll need until tomorrow evening to fabricate some replacement components. Maria, if you can actually fix this thing, I'll double your fee." "That won't be necessary." "Mr. Richardson, I agreed to $20,000 and that's what I'll charge. I'll call you tomorrow when it's ready." After she hung up, Maria sat in her quiet shop, surrounded by the familiar tools and equipment that had become her life. For the first time in 3 years, she felt the old excitement that had drawn her to engineering in the first place, the thrill of solving a problem that others had deemed impossible. Tomorrow, she would show James Richardson and his team of PhD engineers what real problem-solving looked like, not through corporate politics or impressive presentations, but through careful analysis, creative thinking, and the patient application of fundamental engineering principles. Maria smiled as she turned off the lights and locked up the shop. Sometimes the best solutions came from the most unexpected places. Maria arrived at her shop before dawn, eager to begin the fabrication work. She had spent the night dreaming of circuit diagrams and component layouts, her mind already working through the manufacturing processes she would need to create the improved parts. The replacement components required a combination of traditional electronics and cutting-edge material science. Maria began by firing up her chemical etching station, a piece of equipment that had once been used to create experimental semiconductors at a university research lab. The process of creating custom transistors was time-consuming, but straightforward for someone with her background. While the etching process ran, she turned her attention to the quantum processing elements that needed recalibration. These components couldn't be replaced easily, but they could be optimized. Maria spent hours adjusting the magnetic field generators and reconfiguring the control circuits to operate more efficiently. The work required absolute precision. Even microscopic contamination could ruin a quantum processor, so Maria had converted part of her shop into a makeshift clean room years ago. She changed into a protective suit and worked under filtered air systems, using techniques she had learned during her graduate research. By noon, she had completed the first phase of repairs. The power regulation circuits had been rebuilt with components rated for twice the thermal stress of the originals. The protection circuit had been reset and recalibrated to allow for the improved power handling. Now came the delicate work of reassembling everything. Maria worked methodically, checking and double-checking each connection. She photographed her progress at each step, documenting the improvements she had made. This wasn't just about fixing the device. She was essentially reverse engineering and improving upon millions of dollars worth of research and development. At 4 in the afternoon, she was ready for the first test. Maria connected the device to her power supply and diagnostic equipment, then held her breath as she pressed the activation button. For a moment, nothing happened. Then slowly, the device's indicators began to glow as it went through its startup sequence. The diagnostic readouts exceeded her expectations. Not only was the device functioning, but it was operating at efficiency levels higher than the original specifications. The improved power circuits were running cooler and more stable than the factory design. The quantum processors were maintaining coherence for longer periods, indicating better environmental control. Maria allowed herself a small smile of satisfaction. She had done more than fix the device, she had improved it. But the real test would come when James's team put it through its paces under real-world conditions. She was cleaning up her workbench when the shop bell chimed. Maria looked up to see James Richardson entering, but he wasn't alone. Behind him came 3 other people in expensive suits. all looking around her shop with the same barely concealed skepticism James had shown the day before. "I hope you don't mind," James said, though his tone suggested he had come regardless of whether she minded. "I brought my lead engineers. They wanted to see the device before we take it back." Maria recognized the power play. James might trust her enough to let her work on the device, but he wasn't about to accept her results without having his experts verify them. She had expected this and wasn't offended. "Of course," she said politely. "The device is ready for pickup." One of the engineers, a thin man with wire-rimmed glasses, stepped forward. "I'm Dr. Peterson, Chief Technology Officer. I understand you believe you've repaired our prototype." "I have repaired it," Maria corrected, "and improved it." Dr. Peterson exchanged a glance with his colleagues. I'm sorry, I didn't catch your last name." "Santos, Dr. Santos, actually." "Dr. Santos, then. While I appreciate your confidence, this is an extremely complex device. Our entire engineering team has been working on this problem for days." "Then you'll be pleased to know it's fixed," Maria said calmly, lifting the device from her workbench. She had cleaned it thoroughly and polished the casing until it looked brand new. The device appeared identical to how James had brought it to her, except for being spotlessly clean. Dr. Peterson accepted the device carefully, examining it for any signs of tampering. "You opened the casing." "Of course I opened it. You can't diagnose problems through the outside of a sealed unit. But the security seals are intact on the components that matter," Maria interrupted. "I photographed everything before I started and can show you exactly what I did." James watched this exchange with growing impatience. "Can we please just test the thing? We need to know if it works." Dr. Peterson nodded and pulled out a tablet computer. "I have diagnostic software that can run a basic functionality test." He connected his tablet to the device through a specialized port and launched the testing program. Immediately, the screen filled with data streams and performance metrics. Dr. Peterson's eyebrows rose as he studied the readings. "That's impossible," he muttered. "What's impossible?" James demanded. "These performance numbers are higher than our original specifications. The quantum coherence duration is up by 30%, and the power efficiency has improved by almost 20%. Maria stepped closer to look at the screen. "That sounds about right. I made several improvements to the power regulation and thermal management systems." The third engineer, a woman who had been silent until now, spoke up. "What kind of improvements?" "I replaced the original power transistors with custom units rated for higher thermal stress. I also reconfigured the cooling system to run more efficiently and modified the quantum control circuits to reduce interference." Dr. Peterson stared at her. "You modified the quantum control circuits? Do you have any idea how complex those systems are?" "Yes," Maria said simply. "I helped develop the theoretical framework for quantum coherence control during my doctoral research at Stanford." A stunned silence fell over the group. Finally, the female engineer spoke. "You have a PhD from Stanford?" "In quantum physics. I also have a master's in electrical engineering from MIT. James found his voice first. "Why didn't you mention this yesterday? Would it have mattered? You came to me because you were desperate, not because you were looking for qualified expertise." Dr. Peterson was still staring at the diagnostic readings. "These improvements, how did you know what modifications to make?" "Because I recognized several design flaws in your original architecture. The power components were operating too close to their thermal limits, and the quantum processors weren't properly isolated from electromagnetic interference. These are common problems in first-generation prototypes." "Common problems." Dr. Peterson's voice rose slightly. "We've been working on these issues for months." "Sometimes an outside perspective helps," Maria said diplomatically. "When you're too close to a problem, it's easy to overlook simple solutions." The female engineer extended her hand. "I'm Dr. Sarah Kim, lead quantum researcher. I'd like to understand exactly what you did to improve our coherence duration." Maria shook her hand. "I'd be happy to explain, but it might take a while." For the next hour, Maria walked the team through her modifications, explaining her reasoning and showing them the documentation she had created. The engineers listened with growing amazement as she demonstrated not only a deep understanding of their technology, but insights that had escaped their entire team. Dr. Peterson finally looked up from his notes. "Dr. Santos, these improvements would have taken our team months to develop and implement. How did you do this in less than 2 days?" "Experience," Maria said. and the advantage of not being constrained by corporate politics or committee decisions. When you can focus entirely on the technical problem without worrying about meetings and presentations, solutions come faster. James, who had been unusually quiet during the technical discussion, finally spoke. Maria, I have a question for you. Yes? Would you be interested in consulting for Richardson Technologies on a more permanent basis? Maria looked at him carefully. What exactly are you proposing? A consulting contract. You could work from here, on your own terms, tackling problems that our internal team can't solve. We'd pay your standard consulting rates and you'd maintain complete independence. Dr. Peterson nodded enthusiastically. We could really use someone with your perspective and skills. Maria considered the offer. It would mean returning to the high-tech world she had left behind, but on her own terms. No corporate politics, no office meetings, no fighting for recognition. Just challenging problems and the freedom to solve them her own way. I'll think about it, she said finally. James smiled. That's all I can ask. In the meantime, thank you for saving our project. You've literally saved the company. As the group prepared to leave, Dr. Kim lingered behind. Dr. Santos, can I ask you something personal? Sure. Why did you leave the industry? With skills like yours, you could have been running your own research lab. Maria looked around her cluttered shop, at the simple repairs waiting on her workbench, at the life she had built for herself away from the corporate world. Because sometimes fixing a broken toaster for a grateful neighbor is more satisfying than developing cutting-edge technology for people who don't respect your contributions, she said, quietly. Dr. Kim nodded slowly. I think I understand. After they left, Maria sat alone in her shop, the silence somehow deeper than usual. The quantum processor had been a fascinating challenge, but she wondered if accepting more consulting work would gradually pull her back into the world she had worked so hard to escape. Outside, life in the neighborhood continued as it always had, blissfully unaware that one of the most significant technological breakthroughs of the year had just been completed in the little repair shop on Maple Street. 3 weeks later, Maria was attempting to repair an old vacuum cleaner when her phone rang. She had been expecting the call, though she dreaded what it might bring. Word had somehow leaked about her work on the Richardson Technologies prototype, despite James's promise of confidentiality. Dr. Santos, this is Jennifer Walsh from Tech Weekly magazine. I'm calling about your recent work with Richardson Technologies. Maria sighed and set down her screwdriver. I'm not interested in interviews. But Dr. Santos, our readers would love to hear about how a neighborhood repair shop solved a problem that stumped an entire team of PhD engineers. It's an incredible human interest story. No comment, Maria said firmly and hung up. The phone immediately rang again. This time it was a producer from a technology podcast, then a blogger from a popular science website, then a reporter from the local newspaper. Maria stopped answering after the fifth call. By afternoon, a small crowd had gathered outside her shop. Some were reporters with cameras and microphones. Others appeared to be curious tech workers who had heard the story through industry gossip. Maria kept her blinds closed and tried to focus on her work. But the constant interruptions made it impossible to concentrate. The situation grew worse when a news van pulled up and began broadcasting live from outside her shop. Through her window, Maria could see a perfectly coiffed reporter gesturing at her modest storefront while explaining how a simple repair shop owner had revolutionized quantum computing technology. Maria felt the familiar anxiety she thought she had left behind. The attention, the scrutiny, the inevitable questions about her background and qualifications. It was exactly what she had fled from in the corporate world. Her phone buzzed with a text from James Richardson. I'm sorry about this. Someone from our investor meeting leaked the story. Can we talk? Before Maria could respond, another text arrived from an unknown number. Dr. Santos, this is Rebecca Martinez from the National Science Foundation. We'd like to discuss research opportunities. Then, another. Stanford University would like to invite you to speak at our upcoming quantum physics symposium. And another. Netflix documentary team interested in your story. Maria turned off her phone and retreated to the back of her shop. But there was no escaping the chaos outside. The crowd had grown larger and someone was knocking persistently on her door. Finally, she opened it to find Mrs. Chen from the flower shop next door. Maria, dear, what's all this commotion about? These people are blocking my customers from getting to my shop. I'm sorry. Mrs. Chen, I fixed something for a tech company, and now everyone wants to make a big story out of it. Mrs. Chen peered at the reporters and camera crews with disapproval. Well, can't you just tell them to go away? I've tried. They don't seem interested in taking no for an answer. Maybe you should talk to them once, get it over with. Sometimes the best way to get rid of attention is to give people what they want quickly. Maria considered this advice. She had been hoping the interest would die down on its own, but it seemed to be growing instead. Perhaps a brief statement would satisfy their curiosity and allow her to return to her normal life. She opened the shop door and stepped outside. Immediately, microphones were thrust toward her and cameras swiveled in her direction. The noise level rose as reporters began shouting questions simultaneously. Dr. Santos, how did you solve a problem that stumped professional engineers? What's your secret to fixing impossible technology? Are you planning to return to the tech industry? How does it feel to be called a genius? Maria raised her hand for silence, and surprisingly, the crowd quieted somewhat. I'll make one statement, and then I'd appreciate it if you'd all leave so my neighbors can conduct their business in peace. She took a deep breath. I fixed a broken device using standard engineering principles and careful analysis. There was nothing miraculous about it. The device wasn't actually broken. It had shut down to protect itself from some design flaws that I was able to correct. Any qualified engineer could have done the same thing with enough time and patience. But Dr. Santos, called out the Tech Weekly reporter, our sources say you made improvements that the original designers hadn't considered. Doesn't that suggest superior expertise? It suggests fresh eyes and different experience. When you're not emotionally invested in a particular design approach, it's easier to see alternatives. Will you be taking a position with Richardson Technologies? Shouted another reporter. I'm happy with my current work, Maria replied firmly. But surely you could make more money consulting for tech companies than fixing household appliances? Pressed the podcast producer. Maria felt her patience wearing thin. Money isn't everything. I prefer work that gives me satisfaction and allows me to help my community directly. The questions continued, becoming more invasive and personal. Someone asked about her education, another about why she had left the tech industry, and a third about her family background. Maria realized that no matter what she said, they would keep pushing for more sensational angles. That's all I have to say, she announced and turned to go back inside. Dr. Santos, called the TV reporter. One more question. Do you think the tech industry is too male-dominated to recognize female talent? Maria paused at her door. The question hit closer to home than she cared to admit. I think the tech industry, like many industries, sometimes overlooks talent that doesn't fit conventional expectations. But I'm not interested in being anyone's poster child for gender equality or hidden genius narratives. I'm just someone who likes to fix things. She went inside and locked the door, ignoring the continued shouting of questions from outside. The rest of the day was miserable. Customers who might have brought simple repairs were deterred by the media circus. Maria couldn't concentrate on her work with the constant noise and commotion outside. By evening, she felt trapped in her own shop. Around 7 o'clock, the crowd finally began to disperse. Maria was cleaning up her workbench when she heard a gentle knock at the back door. She looked out to see James Richardson standing in the alley behind her shop. She let him in, noticing how tired he looked. I assume you're here to apologize for the media circus? Among other things, James said. I'm truly sorry, Maria. I have no idea how this got out. We're conducting an internal investigation. It doesn't matter how it happened. The damage is done. Is there anything I can do to help? Maria looked out at the street, which was finally returning to normal. You can honor your promise to keep my involvement quiet in the future. Of course. But Maria, I have to ask. Some of my competitors have been calling about you. Word is getting around the industry about what you accomplished. And? They're going to keep coming. This story is too good to ignore. The unknown genius working out of a neighborhood repair shop, solving problems that stump entire engineering teams. You're going to be the subject of articles, documentaries, maybe even books. Maria felt a chill of dread. She had worked so hard to build a quiet life away from the spotlight, and now it seemed that very anonymity was being taken from her. There might be a solution, James continued carefully. I'm listening. Come work for me. Not as an employee, but as a partner. We can set up a subsidiary company with you as the chief technology officer. You'd have your own lab, your own team, complete autonomy over your projects, and most importantly, We can control the narrative. Instead of being the mysterious repair shop genius, you'd be the respected CTO of a successful tech company." Maria studied his face. "What's in it for you? Honestly, having you on our team would be incredible for business, but also I feel responsible for this mess. If working with us can give you back some privacy and professional respect, then maybe we both benefit. I'd still be in the corporate world, still dealing with meetings and politics and all the things I left behind. Not necessarily. We can structure it however you want. You could work from here if you prefer, or we can build you a lab wherever you want it. You'd have final say on your projects and how your work gets publicized." Maria walked to her window and looked out at her quiet neighborhood street. The media attention had reminded her of everything she disliked about being in the public eye. But James's offer represented something different, a chance to do meaningful work on her own terms. "I need time to think about it," she said finally. "Of course. Take all the time you need. But Maria, whatever you decide, please know that what you did for us was extraordinary. Not just the technical work, but showing us that expertise doesn't always come in the packages we expect." After James left, Maria sat alone in her shop, surrounded by the simple repairs that had become her life. Tomorrow, Mrs. Patterson would bring her ancient sewing machine for its monthly maintenance. Young Tommy would probably stop by with another electronic gadget that needed fixing. The neighborhood would return to its normal rhythm. But something fundamental had changed. The secret of her capabilities was out, and there was no putting it back. She could try to return to anonymity, but the reporters would eventually find other stories to chase, and then what? Would she spend the rest of her life hiding her skills, pretending to be less than she was? Or was this an opportunity to find a middle path, one that allowed her to use her abilities fully while maintaining the autonomy and respect she craved? Maria looked at her reflection in the dark window and realized that for the first time in 3 years, she was facing a decision that could fundamentally change her life. The question was whether she had the courage to embrace that change or the wisdom to resist it. Maria spent the next week living in a strange sort of limbo. The media attention had mostly died down, but she found herself constantly looking over her shoulder, wondering when the next reporter might appear. More unsettling were the changes in how her neighbors treated her. Mrs. Chen still brought her coffee every morning, but now she seemed almost reverent, as if Maria had transformed into someone completely different. Tommy had stopped bringing his broken gadgets, apparently convinced that a real genius wouldn't want to be bothered with simple repairs. Even the mailman acted differently, handling her mail with exaggerated care as if it might contain world-changing scientific documents. The steady stream of simple repairs that had sustained both her business and her sense of purpose had slowed to a trickle. People seemed to assume that someone who could fix million-dollar quantum processors wouldn't be interested in their broken toasters and squeaky fans. The irony wasn't lost on Maria. Her moment of professional triumph was threatening to destroy the life she had built. On Friday afternoon, she was reorganizing her tool collection when Dr. Sarah Kim from Richardson Technologies knocked on her door. Unlike the media circus from the week before, Sarah came alone and entered quietly. "I hope you don't mind the unexpected visit," Sarah said. "I wanted to talk to you away from the office environment." "Of course. Can I offer you some coffee?" "That would be nice, thank you." Maria prepared coffee using the ancient machine she had repaired months ago, a ritual that helped calm her nerves. Sarah examined the shop with genuine curiosity, rather than the condescension Maria had grown accustomed to from tech industry visitors. "This is fascinating," Sarah said, studying the electron microscope setup. "You've created a remarkably well-equipped laboratory in here." "It serves my needs," Maria replied, handing her a cup of coffee. Sarah sipped the coffee and smiled. "This is excellent. Much better than the stuff at our office." They sat in comfortable silence for a moment before Sarah spoke again. "Maria, can I be completely honest with you? Please. What you did with our prototype has created quite a stir in our industry. Not just because you fixed it, but because your improvements have opened up new possibilities we hadn't considered. The efficiency gains alone could revolutionize quantum computing. I'm glad it's working well for you." "That's just it. It's working too well. Our investors are demanding to know how we achieved these improvements. Our competitors are trying to figure out what we've discovered. And our entire engineering team is feeling somewhat embarrassed that an outsider solved problems they'd been struggling with for months." Maria understood the implications immediately. You're saying my involvement has created complications for your team? In some ways, yes, but also opportunities. The truth is, our team learned more from studying your modifications than we had from months of our own research. Your approach was so fundamentally different from ours that it forced us to reconsider some basic assumptions. What are you asking me, Dr. Kim? Sarah, please. And I'm asking if you'd consider a very specific type of collaboration, not a traditional consulting arrangement, but something more like a research partnership. Maria raised an eyebrow. Explain. We want to create a new type of position, a remote research fellow. You'd work independently on projects that interest you, with full access to our resources and data, but no obligation to attend meetings, deal with corporate politics, or relocate. Think of it as a bridge between academic research and practical application. And what would Richardson Technologies get out of this arrangement? Sarah smiled. Access to your unique perspective and problem-solving approach. The chance to learn from someone who isn't constrained by our internal assumptions and biases, and honestly, the credibility that comes with having someone of your caliber associated with our work. Someone of my caliber? Maria's voice carried a note of skepticism. Maria, I've been in this industry for 12 years, and I've never seen anyone diagnose and solve a complex technical problem as quickly and elegantly as you did. Your modifications weren't just fixes. They were innovations that our entire team wishes they had thought of. Maria considered this carefully. Unlike James's offer of a corporate partnership, Sarah's proposal sounded more like the kind of work Maria had originally hoped to find in academia. Focused research without the administrative burden. What kind of projects would you want me to work on? Whatever interests you. We have dozens of technical challenges that could benefit from fresh thinking. Quantum coherence problems, thermal management issues, power efficiency optimization, even some theoretical work on next-generation architectures. And I'd work from here? If you prefer. We could also set up a dedicated lab space for you elsewhere if you need specialized equipment. The important thing is that you'd have complete autonomy over your research environment and methods. Maria walked to her window and looked out at the quiet street. The neighborhood was returning to normal, but she realized that normal wasn't quite what it used to be. The media attention had changed how people saw her, and perhaps it was time to acknowledge that her old life was gone whether she liked it or not. Sarah, can I ask you something personal? Of course. How do you handle being a woman in this industry? Don't you get tired of constantly having to prove yourself? Sarah laughed, but not unkindly. Every single day. But I've learned that the best response is to do work so good that it speaks for itself. What you did with our prototype, that's the kind of work that commands respect regardless of who did it. But it shouldn't have to be exceptional just to be acknowledged. No, it shouldn't. But until the world changes, we work with what we have. And right now you have the opportunity to do the kind of research that could change entire fields. Maria turned back to Sarah. What would happen if I said no? Nothing bad. You'd continue living your life as you choose. But Maria, can I be blunt? You're not going to be able to go back to anonymity. The story is out there now. You can either shape how it's told or let others shape it for you. This was the truth Maria had been avoiding. The media attention might die down, but she was now known in tech circles as the repair shop genius who had bested a team of PhD engineers. That reputation would follow her whether she embraced it or tried to hide from it. If I agreed to this, what would be the first project? Sarah's eyes lit up with excitement. We're working on a new generation of quantum processors that could operate at higher temperatures. Current systems require cooling to near absolute zero, which makes them impractical for most applications. If we could develop processors that work at liquid nitrogen temperatures, it would revolutionize the entire field. Despite herself, Maria felt a spark of interest. It was exactly the kind of fundamental challenge that had drawn her to engineering in the first place. What approaches have you tried so far? For the next hour, Sarah walked Maria through the technical challenges and the various solutions her team had attempted. Maria found herself asking probing questions and suggesting alternative approaches. It was the first genuinely stimulating technical conversation she had had in years. You're already thinking about solutions, aren't you? Sarah observed with a smile. Maria realized she was. Her mind was racing with possibilities, seeing connections and potential approaches that excited her in ways she had almost forgotten were possible. I need some time to think about this, Maria said finally. Of course. Take all the time you need. But Maria, I hope you'll seriously consider it. The field needs people who can think outside conventional frameworks. You've already proven you can do that. After Sarah left, Maria sat alone with her thoughts. The quantum processor repair had reminded her of why she had become an engineer, but it had also thrust her back into a world she had deliberately left behind. Sarah's offer represented a potential middle path, a way to engage with cutting-edge research while maintaining her independence and autonomy. She looked around her shop at the simple repairs, waiting for her attention. Mrs. Peterson's radio needed new capacitors. The high school science teacher had brought in a broken oscilloscope that needed calibration. These were meaningful problems too, helping people in her community in direct and tangible ways. But as she considered Sarah's offer, Maria realized that perhaps the choice wasn't between helping her neighbors and advancing scientific knowledge. Maybe there was a way to do both. Maybe she could be the neighborhood fix-it lady, who also happened to push the boundaries of quantum physics. The next morning, Maria made her decision. She called Sarah and accepted the research fellowship with one condition: she would continue operating her repair shop and helping her neighbors with their everyday problems. The simple repairs that had given her peace and satisfaction would remain part of her life, alongside the complex challenges that would push her to grow professionally. As she hung up the phone, Maria felt something she hadn't experienced in years: genuine excitement about her future. She had dared to step back into the world of advanced technology, but this time on her own terms. The simple woman who fixed impossible things was about to show the world what she could really do when given the freedom to explore her full potential. Outside her window, the neighborhood continued its familiar rhythms, unaware that their local repair shop had just become the unofficial headquarters of groundbreaking quantum physics research. Maria smiled as she opened her shop for another day of fixing the impossible, one problem at a time.